Hello. Hello. Hello, Dr. Ramakrishna. Spotlight here.
पर इसका spotlight निकालो.
नहीं, you'll have to share the screen ना. तो ये पड़ा इसमें जाएगा. ये इनका share screen है.
So is it possible? Is it my screen is visible?
Yes, sir. Yes, sir. The screen is visible, sir.
Yeah. Good afternoon. Before starting my presentation, I just want to thank some of the people who are responsible, and like one my friend Mr. Rajshekhar Garu from Jost Engineering, Bangalore, and my guru Ganesh Kumar Garu, Scientist H, NSTL, who are majorly responsible for me to deliver my lecture. And I apologize, first of all, I was not came yet physically because of my son's health condition, but I could do from the virtually. And thanks to all the members of the Council of the Vibration Specialists, like President, Secretary, and all the members. And also thanks to FCRIT team and all the organizers and all the members who has invited me to deliver my lecture. So my topic depicts this vibration testing and vibration control of underwater applications. Like before starting this, I just want to brief about environment testing. Basically, if any system is undergoes certain process like design, fabrication, and manufacturing, and then testing, so the design parameters are to be validated in the testing. The main purpose of this environment testing is the validation of the design parameters for its required performance as per the given standards. That is the main aim of the environment testing, to validate the system performance. So there are different types of environment testings were there, like vibration testing, shock testing, bump testing, temperature cycling testing, and the EMMC, as well as the acoustic testing. But I just want to discuss about the initially about the vibration testing. So what actually meant by vibration? Vibration is nothing but it is a response of a system for a given excitation force. So if you give certain force to any other system, how it behaves, how it responds, that is nothing but the vibration. So if you hit any man, how it responds, whether he will be in a cool condition or hot condition. So that response, it depicts the response indicates the vibration of a system. So any motion that repeat itself for a definite interval of time is also called a vibration or a oscillation. So in the vibration testing, as I discussed about the vibration testing, the main performance is to validate its design for its performance for independent use, because different systems are designed for different purposes. Like some torpedoes are like, if you see the NSTL, we will design certain torpedoes, mines, and decoys. The main purpose we will be validated. It will be designed and fabricated. Once it is fabrication, both the environment testing it should prove, as well as performance also it should prove. So for a particular load, for a particular vibration load, it was designed, but whether it is capable of taking that load or not, we'll measure using the vibration testing. So different types of in NSTL, as it is a naval lab for the DRDO. In the DRDO, we use it to design and fabricate test different types of underwater weapons like torpedoes, mines, and decoys. And this vibration division also used to do the vibration testing of different equipments and the different types of mounts, which will be given by the Indian Navy. Basically, we'll help for the Navy. We'll work for the Navy. So in addition to our products, we'll vibrating testing will do for the naval equipment, naval like compressors, pumps, as well as the turbines, or the viscoelastic mounts. Different types of mounts they will supply for doing the vibration testing. And in addition to, we'll go for the some other equipments like other DRDO labs and other public sectors as well as the private enterprises. So we are the author certification agency for the Indian Navy. HR, any equipment which is going to the onboard ships and submarines, we use it to do the vibration testing, and we'll give the certification. Then only they will accept. Indian Navy will accept. And in vibration test facility, we have the different types of shakers. We have the 60-ton shakers, 8-ton and 4-ton shakers are available of different specifications. Various specifications are there. I'm going to discuss in future slides. So this pictures depicts the top two figures depicts there are a 16-ton shaker system having the 2.5 by 2.5 horizontal slip table and VLS also, vertical load support platform. This is the one of the biggest of like second biggest facility which is available in India, 2.5 by 2.5 size. And this is the 8-ton vibration shaker, and this is the 4-ton shaker. So maximum specification which can do vibrations is a payload of about 3 tons we can do from the 16-ton shaker, and maximum acceleration up to 100 G we can do, and the frequency range up to 2.5 kHz, and up to maximum displacement of 38 mm. And this 16-ton shaker is a water-cooled system, and 4-ton 8-ton shakers is a air-cooled system. So the different standards we use depends upon the type of equipment we use. Some are our naval weapons we use gold for mainly for JSS Penta 5 as well as the MIL standards, and different types of tests we'll do like endurance test, resonance test, sign test, random test, sign on random, random on random in all the 3 axes. So these are the typical equipments which are going to do which will be doing in our NSTL. And these are some of the features as I discussed about. There are different types of test. Like these are the state of art of test facility. As I discussed, it is one of the second biggest, having the 2.5 by 2.5 table size, which is having our facilities, and different types of shakers are available in different types of test we'll do. That is sign test, random test, sign on random, random and random, etc. And these are the some of the components that we'll go using the vibration testing. So this is the one type of testing which we have done for the qualification testing of one of the varieties of torpedo. Like we will do both the sign test as well as the random test, and having the and both the tests, both the test and all the access has been successfully carried out, and it has been approved. It has been done now the validation trials for the Indian Navy. The main principle behind this vibration testing is the Fleming's left hand rule. As we know, there are electric current it shows the thumb finger, and the magnetic flux shown in the forefinger. The force, excitation force, depicts in the thumb. So both are 3 mutually perpendicular directions, and mainly works in the F is equal to BIL. We know the magnetic B is the magnetic flux density, I is the current, and L is the length of the dichrome. And that force, excitation force, is equivalent. Will also equivalent to mass as the product of mass and the acceleration. The total mass indicates the mass of the armature and the head expander, as well as the payload, which payload of the specimen. The main parts, important parts of the vibration shaker, as we know, are we have the controller, power amplifiers, and the electrodynamic shaker, as well as the horizontal slip table, vertical load support platform, as well as the cooling system. These are the some of the important parts which we are the exciter system. So this figure shows the dynamic vibration shaker, mainly consisting of the armature as well as the body. The inside part is the armature, outside part is the body. We have to supply will be given to this armature as well as the body, and the magnetic flux will be generated perpendicular 90 degrees, and the corresponding force, excitation force, will be generated in the vertically upward direction. That is the main energy, main source of energy which is required for the excitation of the different types of particles. And these are the power amplifier. whose the where as we know the given input excitation will be given by using the controller. Controller sends signal to the power amplifier where the amplification takes place. From the amplifier, signal will be going to the shaker, and shaker is connected to vertical load supply or the horizontal platform by using the bull nose connector, and then excitation takes place. The main purpose of amplification power amplifier is to amplify the signal and AC signal converted to the VVF, variable frequency drive. That is the main aim of this power amplifier. And circular head expander, this is a this will be connected to the vertical Z direction and vertical direction, where we cannot accommodate our objects on the directly on the shaker head. So this is a separate unit, a magnesium alloy made up of the magnesium alloy. This will be assembled to the vertical direction, and then object the required for the vibration will be assembled to the circular head expander. Similarly, this horizontal slip table. The horizontal slip table is this is the place where we assembled our object heavy loads onto the horizontal slip table, and we can do the vibrations in both x direction as well as the y direction. And here one oil film is maintained in between the granite surface as well as the slip table to avoid the friction, to reduce the friction. That is the main of the horizontal slip table. And vertical load support platform is directly connected. So as the some of the objects, big objects, we cannot directly connect to the on the shaker head in the vertical direction, that is Z direction. This vertical load support platform for a 16-ton shaker with a 2.5 by 2.5 size, which can be assembled on the shaker head, and objects which are required to the vibration system will be assembled connected to the this VLS platform. This is possible for vibration testing in the Z direction. So this is also made up of magnesium alloy, where it can be high damping properties. And the cooling system, as I told, for 4-ton, 8-ton shaker is air cooling system. For a 16-ton shaker, we have the water cooling system. In the 16-ton shaker, we have there are two and heat exchanger is present in between these, where the temperature which are generated inside the shaker is reduced by using the distilled water. The distilled water circulated from the shaker, and this circulated water will be exchanged heat from the incoming cool water, so that the temperature of the distilled water reduces, the temperature of incoming water is increased, heat transfer takes place between that, and it is a continuous circle. That is the main aim of water cooling system. And we will do the vibrations. Testing with different types of standards, as I discussed. There are different types of standards for the different type of applications. As like for the different types, like rotating machinery standards, the reciprocal machinery standards, and vibration standards for shafting system. For the ship hull, the different types of standards will be there. And some of the standards which are developed by Indian M companies like NTPC and NSTL and ONGC, for the different applications. So like for the standards which are going for the rotating machinery, like SNM standard for the USA, and ISO standards, and BS Bureau Veritas standards are there, VDS standards are there, and Canadian ISO, IS. These are the different types of standards which we use for different applications. For the rotating machinery, for the reciprocating machinery, we have the Bureau Veritas standard, which will be mainly used. As well as for shaft system like propeller shaft or another connecting shafts, there are VDA and APS standards will be used. For the ship hull, there is a Vignes and Hardy limits that standards will be used, as well as the ISO standards. And as I told, the Indians, some of the establishment generator are developed their own standards. Like NSTL, we have our own standard for different applications, and ONGC and NTPC, they are also different standards for different applications. So these are some other vibration testing carried out for the last 20-30 years, like different torpedoes, as I said. We have the heavyweight torpedoes and lightweight torpedoes, and in lightweight again different types of torpedoes will be there, and different components, like we have the access head and tile motor, electronic units, tile section, different types of components I have done for vibration testing for different applications. And in addition to our internal testing, we'll go for other DRDO testing labs also, ADA Bangalore, like pylons, they will be. Because this facility is there in India, we have the second biggest facility. That's many people use it to come for testing. And for equipment from the Bell, VDL, and ECL, different types of equipments also will come for the. These equipments will be mainly purpose of the supplying to the Indian Navy, as also some private companies also we use it to go. So these are the some other equipment we have done the vibration testing. Yearly, broadly, if we will do around 80 to 100 vibration testing will be do, also depending on the workload. So these are the basics about the vibration testing. And the second, my topic is vibration control. Before discussing about the vibration control, I just want to discuss about the stealth technology. So what is meant by stealth? So as we've seen, these are the two types of ships with P and DDX, and other two types of ships, F-218 and D-187. If you see, most of these, all the radars and guns as well as the torpedo launchers are visible to the outside. And if you see these two figures, which are not everything inside that's covered, and which are not visible to the outside, these are the two called the stealth ships, and these two are the non-stealth ships. So what is meant by stealth? So there are different signatures to the ships and submarines. These are the because of the signatures enemy can detect, so that he will hit the our components or our ships and submarines. So in order to avoid the detection by the enemy, we have to create or we have to make our ships and submarines as a stealthier. So how to make the stealth? Like these are the two stealth aircrafts, and these two are the non-stealth, like F-35, so non-stealth aircrafts. These are the two stealth aircrafts. So what actually the stealth technology is? So first of all, we have to protect our ships and submarines from the incoming enemy, like bombs or guided missiles. So we have to protect our marine platforms, like above the water structure and below the water structure. Above the water structure is called the superstructure, and below the water is the structure. So this the enemy can launch their missiles or their enemy bombs from, so that we have to protect our superstructure, and also enemy can launch our torpedoes or underwater mines from the water. So we have to protect from the hull from this from the sea also. So if you become more stealthier, in addition to protection from our equipment, our ships and submarine, we have the chance so that we can hit the first strike capability. So if enemy cannot detect us, we can hit the enemy first. So that we can go near to the enemy, and we can hit the enemy also. So some of these, if these are the non-stealth ships, these are stealth like. So outside, if we create our structure like radar absorbing structure, like radar absorbing mind, radar absorbing materials, and RCS screens, if you create for the strips, and then we will become the this is the one of the signature. Radar cross section is the one of the signature we can reduce from the outside. That is above the water level, and below the water some other signatures are there. So what actually makes this signature means, we have to create our signatures which is to be avoided detected by the enemy. So if we create our signatures equivalent to the our like atmosphere signal, so that we can reduce our noises, or we can reduce our IR, we can reduce our RCS, so that enemy cannot identify this is there is a ship or normal atmosphere. So that is the main aim of this stealth. And because if you become the stealthier, and this is a defense technology, we can go to the enemy near to that, and we can hit the enemy fast. So that we will going to win in the war. So that is the main aim of the stealth. So these are the mainly broadly the spectrum of the stealth. So these are the signatures that are to be reduced to become the more stealthier, like acoustics. In the acoustic, we have the vibration and the noise signatures are there, and IR, this infrared signature, because most of the ships and submarines will be generate some of the heat or the exhaust at certain temperature is there. These signatures are to be reduced. And radar cross section, as we discussed, the shape of the above the water level, these shapes are to be modified to avoid the radar cross section. And this is the LCS, laser cross section, also we have to reduce for the superstructure. And hydrodynamic wake, which is a bubble like structure which is going after the ship is gone. This hydrodynamic wake also to be reduced. And magnetic signature, as the ship is or submarine is made up of the magnetic material, this and earth is a magnetic field is the earth magnetic field. Because of these two magnetic signatures will be developed, these signatures also enemy can detect. These signatures are to be reduced. And ELF, extra low frequency emission signatures are there, because of the two dissimilar material of the ship as well as the propeller. ELFE signatures will be generated. Ship is a magnetic material like iron, and propeller is a bronze and other kind of material. So because the dissimilar materials, as we know, ELFE signatures will be generated, and because of these signatures also enemy can detect. If you reduce all these signatures, and if you make our ships and submarines equivalent to the atmosphere signature, will become the most stealthier, so that enemy cannot detect. So out of these signatures, I will discuss about the vibration acoustic signature. So in underwater, enemy can detect by using the sonar, like let's assume this is the ship and this is submarine. where our sonar will send the acoustic signal, because in air we have the electromagnetic signature works, but in underwater EM signatures won't work. So hydraulic acoustic signature is the mainly useful for the detection in the underwater. So in underwater only acoustic signature will be sent, like it sends the signal and receives the signal. Depending on the received signal, we can identify whether where the ship is there or submarine is there. So there are active and passive modes are there. Passive mode is it will listen the signal, and active mode it will send the signal and receive the signal. Because of this, we can identify the enemy. So maximal Doppler effect will be used for the underwater signature, and mainly around 10 the range, maximum range we can detect up to 10 kilometers. So in the acoustic stealth, it is one of the best method, one of the effective method for detecting the underwater naval vessels. So acoustic signature is the main prominent signature where we can detect. The capability, we can increase our acoustic signature capability by minimizing the acoustic energy created by all the machines. As we know, in the ships and submarine, there are different types of sources will be there, like engines, gas turbines, pumps, motors, etc. All these signatures, because of the unbalanced forces and couples, that energy, the vibrations are to be generated. These vibrations are transmitted from the source to the underwater hull through the path, like from the, and this it will be transmitted from the hull. It will transmitted as a radiated noise inside the water. So these are called the machinery noise. The noise which is generated, the vibrations which are generated inside the engine room is called the machinery noise. And as we know, the propeller which is rotating backside of the ship's hull, this is the, when it is rotating, it cuts the water, it generates the propeller noise. And this is a machinery noise and propeller noise. And as well, when the ship is going into the water, it cuts the water because of turbulent boundary layer excitation on the incoming fluid. The ship also vibrates. That is called the flow noise. The flow noise, machinery noise, propeller noise, all these three combinedly called as a radiator noise. So enemy will detect depending upon the radiator noise signature only. So we have to minimize these signature. If you want to minimize, all these sources like propeller, flow, as well as the engine sources are to be reduced to become the stealthier. So either we can reduce or we can absorb the incident energy. That is then only we can increase the acoustic stealth capability. So this can be achieved. The acoustic stealth can be reduced by using proper isolation method, by using the right kind of damping materials, by using the material of the engine bed, or radiate noise we can reduce, or noise suppression methods, machinery noise suppression methods we can use, or advanced propulsion design we can mode, or increase the sonar capability, or by monitoring our own signatures. So as we discussed, there is a flow, there are different types of noises, are airborne noise, underwater noise, structure-borne noise. Airborne noise is the because of the vibrations, the noise is generated that will be transmitted across the air. And underwater noise, the mainly basically flow noise and propeller noise are called underwater noise. And structure-borne noise is the machinery noise, as we discussed previously. These types of noises are to be minimized to become the acoustically stealth. As we know, underwater there are sound waves also. Sound wave is nothing but the pressure disturbance that propagates. When the disturbance starts, it propagates from one place to another place. It depends upon the medium. The speed at which it transmits depends upon the medium. And the main reason for the sound waves is the vibrating the solid surfaces. So any sound which is objectionable to us is called the noise. The main difference of sound and noise is the noise is not useful, or which is objection for the human ear is called the noise. As we know, the source, these acoustic signal will be generated from the source, and it is a receiver. This will, from the source to receiver, there are, it will transmit the so many paths are there. In between the path, there are these are the airborne noise, and again structure-borne noise, airborne noise. And there are different types of paths will be there, like structure-borne noise, again airborne noise, like airborne noise, structure-borne noise. Like different types of routes will be there. So if we can reduce this acoustic noise either in the source itself, that is better, or if it is not possible to reduce, we can reduce in the path which is generated, which is transmitting, that also we can reduce, or we can reduce in the observer. If it is not feasible in the source or path, we can reduce the observer side. That is the main aim of the we can reduce either in the source, path, or the receiver. These are the three modes of reduction. So because of this vibration, there are certain problems will be observed for the physical equipment, like either the equipment may lead to physical failure or the functional failure. It may not operate, or physically it may get damaged because of the cyclic stresses which is generated, or because of the wear of the bearings or the gearing and the coupling, or because of the vibration it may lead to the failure of the fasteners or the looseness of the fasteners, or because of the vibration noise will be generated. It leads to the discomfort to the human being who is the operator, and as it leads to the malfunction of the equipment itself, it leads to the failure of the floor. So how to control these vibrations to avoid these failures? By proper alignment, the shafts will be properly aligned, or for improving the different types of best materials, or by proper isolation methods, isolation techniques can be made, and proper balancing also be can made, or damping, different types of damping layers, damping structures like free layer damping treatment, or the constraint layer damping treatment, or tune mass dampers, or MR magneto-rheological dampers. We can do different types of control, different types of control you can do, or by changing the structure. Structurally, you can modify by using then we can control the vibrations. These are some other control technique. As we know, the causes of vibration misalignment or unbalance or the looseness of the fasteners. So these are the some of the acoustic signature control methods are there. Like if you isolate the vibrations from the source to the receiver, and or we can absorb the vibrations to avoid the transmission to the receiver, or we can both sound insulation, sound absorption if it is also can take place, or we can reduce the incoming noise. These are some of the techniques to reduce the vibration or the noise signal. So in the vibration insulation, these are the some of the like devices like shock absorbers, or hoses and different types of hoses and sleeves, or vibro insulation joints, or pipe hanger brackets. But if we create this type of equipment, we can isolate the vibration from the source to the receiver. Or if you absorb the vibrations like by using sandwich structures, or vibro absorbing coatings, or viscoelastic filler materials, or vibro absorbing alloys, we can absorb the vibrations. Or noise also, sound absorbing screens, or sound absorbing cabins and jackets, or sound insulating or sound absorbing coatings. If you do, we can reduce or we can absorb the noise levels. Or noise levels we can reduce by using sound insulating coatings, air ducts, or mufflers, or hydraulic noise mufflers. We can use these are the techniques to reduce the vibration as well as the noise levels. And these are the some of the components which will install in the onboard substance apparels to reduce the vibrations as well as noise. Like viscoelastic, as we know, SNV mounts will cause shock and vibration mounts, or different types of mounts will be there. Or these are the different types of mounts are there. Or hydraulic coatings will be like submarine hulls will be mainly used. Use outer hydraulic coating will be there, and pipe hangers, absorbing structures, or pneumatic mounts, or hose connections. Different types of components will be installed to reduce this acoustic signature. So as we know, these are the like basic definitions. Like as we know, drying frequency is the frequency of the forced vibration. Natural frequency of the system is directly nothing but the frequency of the structure when it is operating with the free vibration. And these two vibrations should not be coincident to avoid the resonance. As with the natural frequency as well as the excited frequency, both are matches, it leads to the resonance, which is a catastrophic failure. And this condition should be avoided while designing the structures. And the speed at which the resonance frequency occurs is called the critical speed of the equipment. And some other basic definition, like damping is nothing but dissipation of vibration energy into heat energy. That is nothing but the damping. And the undamped and the damped vibrations also to be there. And some of the acoustic products which has designed, fabricated, tested and onboard ships for the last 20 to 30 years in the NSTL. And these are the some of the equipment will be carried out to reduce these noise levels. The two-stage isolation system, acoustic silencers, acoustic enclosures, and damping treatment, free layer damping and constraint damping treatment, and advanced damping materials, and TMDs, tuned mass dampers, MR dampers, magneto-rheological dampers, and thermoacoustic silencers, and active noise cancellation techniques. These are the types of some other products will be developed by NSTL to avoid the detection by the enemy, to become the more stealthier. So first of all, discuss about the vibration isolation. What actually meant by isolation? Vibration isolation is nothing but to avoid the transmission of vibration from the source to the receiver. That is any pump or gas turbine will be resting onto the foundation, and from this foundation, hello, sir, hello. Yes. So this will be vibrations are transmitted from the source to the receiver to the foundation. In between these, there are two types of systems. Like let us assume, like this is a forced vibration of the, let us assume, the spring mass damper system, which is connected to mass system. This, in between that, if you keep some springs or the dampers, we can reduce the vibration from the source to the receiver. And this is the vectorial representation. And main aim of this is the main intention is transmissibility. Transmitted is nothing but the force transmitted, force applied. The transmit force, the force applied is to be reduced to the from the hull. This is the transmissive curl. Basically, we have to create the this is the isolation zone. This is the amplification zone. If the omega by omega n is equal to 1, where the resonance condition is occurred, where the amplitude transmissibility will be increased to infinity. And our aim is to design the structure, the isolation zone, where omega by omega n greater than √2. There we can apply different types of damping treatment to reduce the transmission. This is the our design area of zone of intention, where omega greater than √2. This is the compressor, engine compressor, where the foundation. If we use the single stage mounting system, then vibration transmission from the source to receiver will be less. Instead of that, to avoid the to increase the more isolation capability, NSTL design two-stage mounting system, where first stage common raft and second stage mounting system. These vibrations are transmitted from the then vibration isolation will be increased. This is the typical two-stage isolation system. As this is the two-stage isolation equations, and this is the design procedure. I just skip all these slides. And these are the typical two-stage mounting system developed for the Navy. Like two-stage developed a motor-driven HB compressor, where its vibrations levels are reduced around 20 dB for a broadband frequency. This is the two-stage mounting system developed for the refrigeration plant, and this is the two-stage mounted BMA pump for the Indian Navy. And all these Navy has recommended for the to develop these two systems for further ships and further equipments. These are the TOS software. And second control method is vibration control by damping. There are different. Damping is nothing but the viscoelastic nature of the material, like rubber product. It has the two elastic nature as well as the viscous nature. Both this nature is mainly useful to reduce to convert the vibration energy to heat energy, like some of the equipments like rubbers, foams, thermoelastics, and enamels and the plastics. And instead of ends modulus, this component mainly consider complex modulus, where it consisting of E prime and E double prime. Storage modulus as a loss modulus. That is nothing but the loss modulus is the energy that is going to be lost. That is the conversion of a vibration energy into heat energy is called loss factor. And this is the equation for loss factor. There are two mainly. We have the two types: free layer damping treatment and constant layer damping treatment will be there in the tuned mass damper also. So main difference between these two is the FLD free layer damping treatment. Mainly it consisting of two layers. That is the base layer we have to bond with the damping material, and the vibration conversion takes place by using elastic nature or the bending treatment. And this is a three-layer structure, where vibration structure divide on that viscous layer is to be bonded, and above the constant layer. This is the constant layer structure. Both are useful for different applications. Some are useful for different. One application, like this is a loss factor equation, where the higher the loss factor, higher is the conversion of energy. And this is the design of the FLD. And this mass sticker, the FLD has been applied at the some of the areas and the barge as well as the inside the ship. And there is a drastic reduction of vibration levels has been, and vibration as well underwater noise also can be applied around 20 dB for a broadband spectrum. And this is the CLD damping treatment, which was designed by using the RK equation, Ross-Kelvin equation. And these are the applications where we have different foundations, different base plates, and different equipment inside the ship have been carried out and reduced the noise levels as well as the vibration level. Finally, is a tuned mass damper. The main aim of the TMD is use vibration reduction of the tonal vibrations. As we know, at the natural frequency, the vibration levels are more. If you want to further reduce these at the tonal vibrational, we have to incorporate the different types of separate equipment onto the assembled these TMDs around the main base source, so that the base source vibration level will be reduced. Instead of that, and instead of these will be vibrated, the noise vibration levels of the base source will be reduced. In here, the main important factor is the natural frequency of TMDs as well as the motors should be equal. Then only we can transmit the vibration levels. These are the typical seawater pump test results of the TMDs. And last in the MR dampers, the magnetorheological dampers, where it is the main aim of this, the change of the flow properties of these particles so that the vibration levels can be reduced. Main important components are the iron particles and the mineral oils will be generated. If you supply the magnetic field or the electricity, there will be a chain-like structure will be generated where the viscosity of the particles will be increased, the vibration levels will be reduced because of this MR dampers. These are the MR dampers application and tested in the Indian Navy ships. And finally, active vibration. Till now, we have discussed about the passive devices, all these vibration isolation, damping, as well as the MRD. These are the passive vibration control. Now we'll discuss active vibration control. The main concept in the active vibration is if you send the signal reverse to the incoming signal, then it will become the active vibration. There are certain instruments we have to use like sensors and the controllers, the actuators to give the reverse signal to the active vibration control. And semi-active devices are like fully active and semi-active are there. In the semi-active, electrodynamic shakers and piezoelectric ceramics as well as electro-hydraulic devices will be there. And semi-active is the MR dampers of shape emeralds mainly used for the semi-active devices. And this is a typical system for the main principle is the output signal, vibration levels are measured by using sensors where controller sends the signal to the power amplifier and the actuator will send to the negative or the reverse of the input and signal so that the vibration amplification will be nullified. That is the main concept. Like if it is the primary source, this is the signal which is going to send, and finally the signal becomes the nullified. The output signal will be the 0. That is the main aim of this one. This is the forward feed control, feedback control also there. And this by using the active vibration, active damping, the vibration levels will be reduced up to certain frequencies. This ends my presentation, and my sincere thanks to my director, Dr. Y. Srinivas Garu, outstanding scientist, and my TDs, Krishna Kumar sir and Ganesh Kumar sir, and all the departments who has helped me to deliver my lecture. Finally, my sincere thanks to Rajshekhar Garu, who has given me an opportunity to share my knowledge to all of you. And finally, thank you and Jai Hind. Thank you.
Share screen. स्क्रीन विंडो उसमें से विंडो उसमें वही पॉइंट नहीं सेकंड क्या होगा शेयर करो सर इसको वन ऊपर आ जाओ स्टॉप शेयरिंग करो हाइड एंड वन कम अप
Thank you, sir. Thank you, sir, for joining us online and for informing us about the applications of vibrations and vibration controls and naval components. Now we'll move on to the technical session for the track of vibration monitoring and diagnostics. And before we begin, I just wanted to inform everyone, for each of the sessions, we will have one session chair and 2 judges. And for the technical session 1, our session chair is Dr. K. Lakshmi. And our judges are Dr. Nitesh Yelve and Dr. Sanjay Rokhande. And they will be, of course, judging the papers, and we will be awarding 2 awards, Best Paper and Best Young Researcher. And for each of the sessions, we'll be having 1 session chair and 2 judges. Now, for today's session, we have 2 papers, and according to the schedule, we have our invited Dr. Chinmay Kar, who will be presenting his paper in the second session. So we'll immediately begin with the first paper for today. It will be presented on the topic of experimental fault identification in journal bearings using vibration-based condition monitoring by Ms. Pallavi Khere, Department of Mechanical Engineering, FCRIT Vashi, and Dr. Vikas Palle, Department of Mechanical Engineering, VJTI, Mumbai. And the second paper for today will be, the topic will be a statistical model of a random forest, a multitude of decision trees for condition monitoring of face milling cutter through spindle vibrations by Atharva Jogdeo, Atharva Atnurkar, Pradnya Sonar from the Department of Mechanical Engineering, Pune Vidyarthi Griha, College of Engineering and Technology, Pune, and Amil R. Borote and Abhishek Patange from Department of Mechanical Engineering, College of Engineering, Pune, COAP, And now I hand over the session to our session chair, and I request our presenters to begin the presentation. Just before we begin, I just wanted to give the information about the rules. I request all our presenters to keep the presentations for 10 minutes duration, after which there will be an interaction with the judges. And once again, I request all the delegates and the participants to please switch off your cell phones. And if you have to take a call, please leave the hall and take a call outside. Thank you, everyone.
Most comfortable application.